and you're filling in your notes, are 3 types of ways of graphing. If we graph an equation and the solution is a point of intersection. So usually when we graph, if we are looking at our answer is always x comma y. It's that point of intersection. Keeping in mind as you're writing it that the x goes left and right and the y goes up and down. Parallel lines means no solution. Again, we're on page 20. The same line means infinitely many solutions. On the test, you will have either one of these. It might be on the graphing, it might be in the substitution, or it might be in the elimination. But you will not have more than one. Okay, so it'll either come out. When we do substitution, again, our answer, x comma y. We substitute x or y when equals to the other equation. You take that solution and you substitute into the other. A true statement, if we are writing down, is infinitely many solutions. So the same as the same line, okay? A false statement is no solution.
Good morning, everybody, and sorry for
the elimination is when we get the columns lined up. You have the x plus the y equals a number. Sometimes I might have to multiply by a number so that they cancel. Next, I'm always going to add or subtract, and I usually want you to add, and instead of subtracting, we've talked about this being multiplying everything maybe by -1 to eliminate the variables. We still take the solution and we substitute it into the other one. So when you do elimination, you're still going to have an x comma y answer on the test tomorrow. The thing that's going to be different, again, these last two, true statement, what do you think I'm going to put? That is always going to be our infinitely many solutions, right? And a false statement is still going to be no solution. So, as you are looking at that top part, that's just kind of the, hey, this is going to be your answer. I will tell you on the test, there will either be one of these no solutions or infinitely many tomorrow on Thursday's test. It'll either be from an elimination where you got a true equal true or substitution, a true statement, 0 equals 0, and you say infinitely many, or it will be the same line, or it'll be a parallel line, or it'll be a false statement to get the no solution. So it says, when is each method best to use on that bottom half of yours? So graphing, if I need to estimate the solution, and it's not exact, when is this the best? Well, graphing, if I just want to estimate it, because I can just kind of draw a rough sketch. If I have a graphing calculator or technology, now when we do this project, you're going to want to use that Desmos calculator to help you out. Okay? You can't use it on the test. You can use it on our project. If the equations are in slope-intercept form, right? Because if they're in slope-intercept form, please write that down, y equals mx plus b. That is so nice if I have it in that form, because if I do have it in that form, where I have it in slope-intercept form, I know that the b we would put behind that tells us where to begin. It's always 0 and then b. The m tells me how to move. I always want to write it as a fraction and put the word rise over run. There was a few of you that retook that graphing quiz, and putting this down helped you a ton. And then the other thing is that slope face, right? So a positive, and this is always for my slope, a negative slope. Make sure I make that negative, with the eyebrow going down. If you have a 0 slope, that's my mouth, and the nose with a U under it for undefined. So if you're filling that in. That really seemed to help people when they took their quiz. They put that behind it as they did the graph. So putting all that information is a suggestion that I would have as you're doing those. When we substitute, it says you know at least one equation already is solved. That's when you have like y equals something, or you might have had x equals all by itself. Do you have something to write with? I have pencils back over there if you, or a pen. You might want to just grab a pen so you don't have to sharpen it. It's easy to solve for one, and it's not as easy to graph them. So they're like big numbers or really weird slopes or something like that. You don't want to graph it. Elimination, one set of variables has the same or opposite coefficients. Coefficient, that's just the number before the variable. So please put right behind coefficient, put the number times the variable. You might hear me use this a little later this year, that word coefficient again, so that definition. It just means the number before the variable. So it's really easy to multiply maybe one and eliminate, and it's not as easy for substitution or elimination. They're just kind of uglier equations, okay? So what's on the test? You see the next page, it says what's on the quiz. I want you to change that word quiz and write test. It is going to be Thursday, so we're on page 20 is where we're at, because we're writing this down. So ours is going to be a test. It is going to be Thursday, so that will be 211. There will be, that is 8 questions worth 40 points. When I put it in as a test, that 40 becomes 100%. Right? So I take your score out of 40, I divide it, and I put it in as a percentage. The first thing I'm going to ask you to do, I can solve a linear system by graphing. 2 questions. I'm going to usually look for that you graph the equation correctly. Each one, that the line is sloping the right way, that you have everything. And then I'm going to look for the solution. When I look for the solution, again, it's going to have to be an ordered pair, x, y, or you're going to have the no solution, or you have infinitely many solutions. And that's kind of going to be the case with all of these, right? Then you're solving algebraically 2 questions. Then you're going to solve with elimination. So the first time, it's going to be a substitution one. And I will not make it hard. I'll give you either the y or the x equal. But your answer is still going to be like this, right? These are going to be our answers for every single one, right? So you have to be able to do the substitution. You have to be able to do the elimination. And then I'm going to give you an equation. So the last one that I want you to put down. So it's graphing. I can solve by graphing, substitution, elimination. I can tell the slope and y-intercept in an equation. I will give you a nice equation like this. Y equals, and I'll have maybe 2x minus 3. And I'm going to say, what's the slope? What's the y-intercept? I would look that you would tell me the slope, as you are writing this, is 2, and the y-intercept you tell me is negative 3. So there'll be one question like that. And then the last one, it's going to ask you to explain, how do you substitute? What does substitute mean? And my hint will be, look back at what you did in our equations. When you substitute and either find the y or the x, you replace the variable either with a number or with a expression, and you solved and you made sure it worked. So being able to explain that, okay? To do other graphs, you need to do 5. I don't care which 5 you do. There's 6 of them, right? You probably are going to do maybe the first 5. I don't know. First thing I need for you to do on the test I will give you, but please right now draw in a y-axis. Put y by it, and then x kind of down through the middle. And you should do that on each graph. And this is my hint as we do the graphing, is that you write the equation in slope-intercept form, so you're putting down y equals I'll even touch my pen. At the top, I might put y equals mx plus b. And then I might go behind the first equation and go, oh, I look at the slope and key on which way would it be going, up or down? Up. And I look at the second equation and jack, which way would the line be going, up or down? Jack over here, up. I got two jacks, I forget. So if this drawing that slope face helps you with the positive and negative, you might put that to help you, right? How did we get that? We looked at this one being 1 and this one being 2. Oh, my beginning, I might write down, is 2. My slope for this first one, m, was 1 over 1. That meant rise over run. I'm not going to graph any of these because this is me trying to see what you know and hopefully help you out. But that would be the information that to me as I look at this is pretty important, and as I'm looking at it, it's going to help me graph this first equation the right way. I put the beginning, the direction, and my slope. I might do that same thing for the second equation. Put all that behind it. Then I'm more likely to graph it correctly. Then if you take a look at that next section going down, you have 4 to 11. Again, I only want you to do 5 of those, right? So this is your substitution. When you look at this, you must do 5, right? From this section. I don't care which 5 you do. On the top of the next page, you have more of your graphs. And then you need to do 5 total graphs. So going across the top, 5 of them. Then from the elimination, you must do 5. Okay?